Hey, hello everyone. Hello developer. José Silva already said here. Hello everyone. Hello José. Good to see you here. Hello developer. I am João Lucas Farias. I will be your host today. Today we will be talking about building a recommendation engine with Redis Graph with a guy, not the guy we talked in the last day, but a guy named Brian Sam-Bodden. Brian, hello. How are you?
Hey, I'm not guy, I'm the other guy. So, hi, everybody. Hello, and welcome to Building a Recommendation Engine with Redis Graph. Hey!
Hey,
So,
you
I am
are.
Brian Sam-Bodden. I am your friendly developer advocate from Redis Labs. I have only one thing to say in Portuguese. Boa tarde, meus amigos. Boa noite. Boa noite. Meu
Now
nome
it's boa
é
noite.
Meu nome é Brian, eu vou falar sobre o Redis Graph. Sou do Panamá e falo um pouco de português. Sou programador há mais de 30 anos. Também sou praticante de jiu-jitsu brasileiro. Sou faixa preta. Adoro feijoada, pão de queijo e cachaça. E gostaria de ter a coragem de fazer esta apresentação no meu idioma, talvez da próxima vez.
Actually, I mean, na verdade, você tem um português muito bom. Parabéns.
All right.
Okay, and just before we start, I can do a challenge for you to come back more time and do a presentation in Portuguese if you want.
I'll do that. Give me maybe 3 months.
Okay,
and
okay.
I'll practice.
I will put this in my to-do list, so I won't forget.
Perfect.
Okay, just guys, don't forget to subscribe, to smash the like button, the bell, to tell your friends, and stay tuned in our social medias just to see all the news we are doing. And now you can do your show, Brian. It's all for you.
Thank you. All right. So today we're talking about building a recommendation engine, and we're going to do that with Redis Graph. And like I mentioned before, like Joao said, I am Brian Sam-Bodden. You can find me on Twitter at bsbodden. And if you have any questions after the presentation, you can email me at bsb@redislabs.com. So let's get started and talk about recommendation engines. And nowadays, we have so much data, so much information. If you go imagine going to Amazon or any other Mercado Libre and not having recommendations. How do you find anything? Search can only do so much. So you need to have a proactive way to find things, which basically is recommendations. And then you have a reactive way to find things, which is search. And sometimes search and recommendations work together, where based on things that you search, the system can also recommend things. But why do we need recommendations? We need recommendations because there's too many choices. And one of the things that happens when you have too many choices is that you freeze. When you have too many choices, you basically are paralyzed. So we're looking to have a balance between having choices, but being able to act upon those choices. So there has to be a balance of how much is there, how much do you go hunting for, and how much it's pushed to you. So the same thing applies to basically freedom and commitment to doing something. If you ever gone to the supermarket, especially in the US, let's say you go to the aisle that has cereals, there would be so many flavors and combinations of cereals that you could spend your life in that aisle and die at the supermarket. You also, so you want to find a way to basically narrow down in a fixed amount of time how to make a decision. And to make that decision, you need to have some choices. You don't want to feel like you're being forced into something. And you also want to have the ability to use some rules in your mind to pick something quickly. And the idea of having recommendation in recommendation systems It's to help you with those rules that you build in your mind. Like, for example, if you go to the cereal aisle again, you might say, hey, I want to find a cereal that doesn't have too much sugar, that doesn't have artificial colors, that tastes like cinnamon and nutmeg and things that are more warm from cold weather, but not like fruits and apples and mangoes and things like that. So you have rules built in your mind, and recommendation systems should allow you to use those rules quickly in the when you're faced with choices. And the same thing in the other part of this equation, it's that you want to be able to also not miss something just because you don't know about it. And recommendations are supposed to explore and find things that you might not know that you like, or you might not know that you need. So we need them to combat that paradox of choice, having too many choices, to deal with the amount of information that we have in the world nowadays. And also we want to, if you're running a business, you want people to act upon the offerings that you have. Like, for example, you want them to go into your website, you want them to pick something and possibly pick more things than they initially came to look for. Or if they came without knowing what they wanted, try to do a best guess of what they need. And obviously nowadays we have cookies from every other website in the world, information sharing, information stealing, places like Facebook, for example. Every time that you have a conversation with somebody about some product, the next few days you will be bombarded with advertisements for that product. So that's also goes too far into invasion of privacy too. So there's got to be a balance between all those things. So user expectations, how to keep your users happy, to feel that you're providing adequate, actionable information and hints, but not invading their privacy or not knowing too much about them. So the recommendation engine, it's a system that predicts a level of user interest on something, an item. And the item could be anything. Could be a shirt, a pair of shoes, a motorcycle, anything. And you want to, with time, provide personalized recommendations. So there's a process of learning about your users too. And so we have a recommendation engine, a system that needs to use users' actions. So for example, when you click on something, when you scroll through something, when you pause to read something, e-commerce systems try to gather that information. How long did this person stay on this page? Even how fast did they scroll through this page? Did they scroll slowly? Can we infer that they were reading the page, not just looking at the pictures? And once they start taking actions like that in the system, you want to record all those actions. And also, you want to provide a place for them to outright give you information about themselves. Like, you can gather things like gender, age, part of the world they live, they're coming from, things of that sort. So information that's created from actions and information that's created from preferences or willingly given information to the system, it's used for recommendation systems. So an item, like I said before, could be anything that can be represented. It could be books, movies, a travel destination, an exercise program, an article, a recipe, clothing, shoes, anything. And everybody's pretty familiar with Amazon. Amazon was one of the first systems that actually heavily used recommendations. And recommendations are created in a lot of different ways, with artificial intelligence algorithms, with basic statistic algorithms, with simple SQL queries. And we're going to see today how to do that with a graph database. Also, if you, during the pandemic, I think probably all of us watched everything that was on Netflix. And I think at that point, it became very important for the Netflix recommendations to be good. I really wanted to basically, and I think I probably fed so much information to Netflix from watching everything that it really got to learn about me. For example, another place that actually does really well recommendations is Zappos. They do a lot of things with colors, fabrics, the feel of a shoe. So they do a lot of real deep machine learning and computer vision to do a lot of things with recommendations. And if you remember, back in 2009, Netflix created a contest to basically have somebody come up with a better algorithm to recommend movies and TV shows. And that, in my mind, was one of the crucial points into this new resurgence of artificial intelligence and machine learning and deep learning. So, it really made machine learning sexy again, and everybody wanted to become a data scientist at that point in time. So there's a few approaches to basically building recommendation engines, and some of them, and I apologize, some of the text here is a little bunched up, but some of them are based on collaborative filtering. So basically taking information from the actions globally of all your users and using those to basically provide recommendations for a specific user. And others are based solely on content, where, for example, let's say that you have read a book that you like, and we can take the text of the book and create a system that compares how similar that book is to another book, and then we can recommend books based on the content being similar between two books. And of course, in the middle, it's where what most people would do, which is a combination of using the content that you have. So if you're talking about books, it could be the content of the book, the reviews of the book, and things of that sort, how many stars, how many reviews the book has, you can also find sales figure and find books that are popular, and use all that information to create kind of like a Drake equation of recommendations. And a lot of places keep on, they start with something simple and they keep on adding more and more segments of how to figure out whether they want to recommend something to you or not. So then obviously you can do a lot of this based on algorithms. You can do it with data mining and machine learning algorithms, and also with simple similarity algorithms. Like, for example, you can grab the text from an article and you can turn that into a bag of words, and then you can turn that bag of words to some kind of vector in n-dimensional space, and then you can do that for all the articles that you have, and then compare those vectors in space to see which ones are similar to another. So you can say, this article is similar to this article because the two vectors that represent the articles are kind of pointed in the same direction, and they have about the same, the same size. So let's talk a little bit more about collaborative filtering. So basically click-based filtering. And in this type of filtering, again, we want to collect large amounts of user feedback. We want to collect it explicitly and implicitly. So implicitly, when they're doing something like, for example, reading an article, and how fast do they move through the article? Do they go back to the same article? Or explicitly by asking them, he's like, hey, did you like the article? How many stars will you give the article? You use that to basically infer a profile of what that user likes and what type of content they like. So collecting feedback, again, explicitly we have likes, ratings, reviews, wish lists. Implicitly we have things like purchases, searches, browsing, views, and even the duration of those views. And then, obviously you have to take into account, what is positive versus negative feedback, and come up with a scale that basically works for your particular system. So for example, here it's a few reviews that I did, long time ago. So you have star ratings, you have the title, so you can basically do sentiment analysis and basically say whether does the title of this review, it's positive or negative? Or is it, does it express sadness, anger? All those things we can do also with natural language processing. And of course, if you have reviews that have a text, a body of text, then that is a lot of information that you can mine for keywords, again, for sentiments and things of that sort. So the field of collaborative filtering, it's very complex. There's a lot of things that can be taken into account, and there's not a single formula of how to do it right. So sometimes what happens is that there's so much information and so much complexity out there that we don't do anything. So today I want to show you basically simple ways to get started with this that then you can enhance with things like statistical methods, simple similarity algorithms, and then you can go crazy and do machine learning and natural language processing and things of that sort. So again, we can use ratings to find similar users or items. So sometimes you have a user that has a profile well defined, and you have a new user that doesn't have a profile, but you find a way to find a similarity with those users. So then you can say, well, I'm going to guess that since these two users are similar, they might like similar things. And then you use all that information that you built for a different user to make intelligent guesses for the new user. So recommend items that have basically high similarity, or recommend items that a user has purchased or viewed to another user that is similar to that user. So then obviously that leads to user-based recommenders. So finding customers who are similar to you that also like something which I mentioned before. So again, relies on finding similar users, and then you want to do the similarity based on the items in common that they have. And you basically want to use similar user ratings to basically predict a rating for that new user or that new item. So predict how much or how likely it is for this user to give an item 1 star, 2 stars, 3 stars, etc. So again, user-based filtering. You have 2 users, and they have some items in common in the middle. And then you're going to use that space of items in common to basically now look at the items that are not in common and say, oh, okay, so this person likes coffee and t-shirts. These 2 persons like coffee and t-shirts. But this one person likes video games and the other person likes electronics. So maybe we can recommend video games to the person that likes electronics and electronics to the person that likes video games. And then you have the other version, which is item-based recommenders. And when you have item-based recommenders, you want to find basic similarity between the items. And to do that, you have to have enough information about the items. So for example, the example that I used before, books, is a really good one because you have a large amount of data. On the book itself, so you have the title of the book, probably has a table of contents. It likely has a summary or an abstract in the front cover or the back cover of the book that you can use that as, hey, this is the most condensed information about this item. I can do something with this to compare with other items. So typically, when you have a new system, you don't have much information about your users, so you start with item-based filtering first. And as you build profiles for your users, then you mix the two. And again, on item-based similarity, we find that now the people are in the Venn diagram. So when you have 2 people that have something, 2 items that have people in common, now we know that we can use the people on the outside of that intersection, that union, to basically show them or provide hints about items that they might like. So the advantages of over user-based filtering is like items do not tend to change. People do change. Your taste will change over time, sometimes rapidly, but items tend to remain static. With items, you have a smaller data set to deal with. And again, you don't have the human factor, which is kind of the thing that makes it so complex to basically create a profile for a human. Item similarities are faster to compute, and they're cheaper to store too. And they have less legal and ethical ramifications. How much data can you keep from your users? Or how much derived data can you keep about your users? And are you legally allowed to keep that derived data with the data that they provided to you? When they tell you to delete their provided data, do you have to delete some of the derived data? There's a lot of things, especially in the US and Europe, that where privacy laws get very complex about that. So now let's talk about graphs. So now we have an idea of basically what recommendation systems do, what they're used for, to basically just find things that might be of interest to a user, and to basically build this intelligence about offering things to your users, so you can basically in most cases close a sale or provide better service. So let's talk about graphs. And I really like graph databases and graph because in my mind, they are a better representation than, let's say, tables. A relational system, has the word relational for relations, but it doesn't do as good of a job as making those relationships obvious. And graphs do. Graphs are very simple to understand. The thing that I really like about them is that they encode knowledge, and in a way that you can sometimes visualize the knowledge and extract it and see the patterns in the data in a much clearer fashion than with a relational database. So querying a graph encodes knowledge in my mind, and querying a graph gives you access to that knowledge. So therefore, they're in my mind, ideally for storing highly connected data, which is kind of like the definition of a graph. So graphs are simple to understand. Obviously, a graph can get very complex, but at the root, there's basically only two constructs. You have nodes that represents entities, things like party, places, things, a category, even a moment in time, and relationships represent a way to connect those entities with some kind of action or relation or something along those lines. So we talked about recommendation systems, graphs, again, nodes and relationships, and now I'm going to talk a little bit about Redis. In Redis, did I mention that I work for Redis Labs? Redis, it's a superb database. And before I started working for Redis Labs, I really didn't think of Redis as a database. I thought that Redis was just a cache, something that I can put data in memory in between two things so the end user can get the data faster. And Redis does that, and it does it so well that it hides some of the other things that it does also fairly well. So I've been using Redis actually since 2014, and I mainly used it as a cache or a PubSub mechanism. When I was doing a lot of Ruby on Rails applications, and that's kind of how Redis was mostly used in that world. And then once I started working for Redis Labs, I discovered that there's this whole universe of things that Redis can do. And I don't think of Redis as a cache or just as a data type server. I think of it as a multi-model database. So let me kind of give you a quick introduction to Redis. So for those of you that haven't seen much of it, and I know that you had a whole week of Redis developers talking to you, so it's likely there's going to be some overlapping here. So I'll try to move somewhat fast through this. But again, it's very likely that you've seen Redis before. Developers really like Redis because it's easy to set up. It works really well. It's reliable. It's fast. So I'm just going to give you this quick introduction. So Redis, it's the remote dictionary server. So it started really as a very simple data structure system, storage system, in-memory storage system, to basically speed up other systems. So it was really a cache at the beginning. And that's where the letters from Redis come from. And Redis it's always thought as an in-memory only database, but it's only an in-memory first. Redis can persist to disk, to flash, to any other place that normal databases can persist to. But one of the most common use cases is to use it in memory only. But in most of my examples, I use it in memory, but I also persist the data to disk. So you need to think about Redis as a normal database, well, a non-relational, a NoSQL database. So the persistence it's optional, but it's basically a flag that you can turn on and off. So I like to think of it more as a remote data structure server, but I don't think this name will actually become popular if you look at the initials. So the Redis has a lot of different data types that it supports natively. The plain install of Redis will give you strings, will give you bitmaps, bit fields, hashes, which is probably the most common data type used in Redis. You have lists, you have sets, sorted sets, which are very useful to do some really interesting things. Basically, they have a sorted set has the normal elements that a set would have, but also has a weight or a float value, a double value that can be used to do interesting things with the order of that set. You have geospatial indexes natively built into the platform, and then you have basically the non-deterministic, probabilistic algorithms like hyperlog, and also we have a module that adds more probabilistic algorithms. And we have streams, so like similar to Kafka, you can basically have data streaming into your system. Same thing with time series. We also support time series, but it's outside of the plain install of Redis. So to launch a fully loaded Redis instance, the easiest way to do it is with Docker. So what I'm going to show you today, it's using Docker to basically run the Docker image called Redis Mod. And Redis Mod includes all the modules, including Redis Graph. And it's probably the easiest way to get started with Redis++, with all the Redis plus all the amazing modules that are available. So I'm going to jump to the CLI now and basically talk about some of the basic functioning of Redis, and then we'll move into basically building a recommendation system. So let me go ahead and let's go to the terminal. And on one of these terminal tabs, I am going to basically use the Redis CLI, which is the most common way to interact with Redis. So when I run the Redis CLI, notice that I connected to my local server on port 6379. On this other tab, I'm going to also start another copy of the Redis CLI, but this time I'm going to start it with the monitor command. And the reason I do that is so when I do something on this instance of Redis or the Redis CLI, I can basically get a feedback of what it's being sent to the server, and that way it's very easy to debug and to understand how things work. So I just use the ping command, which basically sends a ping to the Redis server, and you can also pass a message like hello, Sao Paulo. So I can send that, and it basically is going to echo back that. So the POM basically now is just a message. And you can see that Redis, the Redis protocol is very simple. I have the command here and nothing. In this one, I have the command and one parameter. Very simple functioning. So then one of the most basic data structure is just a string. So I can say set the let's say a name to, let's say, Brian. And again, if we look at the Redis CLI monitor, you can see that I invoke the set command with two parameters. Name, in this case, would be the key, and Brian would be the value that I'm passing to that key. So everything in Redis actually works off of a key. And now I can get that key back by just passing the key name in the get command. And the same thing applies to most of the other data structures and also the data structures that the modules provide. So obviously, there's a lot of different commands and data structures. I'm not going to go into those heavily because I'm pretty sure that Royce and Simon Prickett probably already cover a lot of those. So I'm going to, before we switch back to the slides and talk about what we're going to build, just show you that the instance of Redis that I have in here has all the modules installed. So when I do the list of modules, notice that I get this array of values, this list of values. So I have the time series module installed, the Redis JSON module installed, which basically makes Redis works like a document database. I have BF, which is the Bloom filters. I have the search module. And I have Redis Graph, the AI module, RG, it's Redis Gears, AI module, Redis AI, and then the one that we're going to be playing with today, Redis Graph. All right, so now let me switch back to the slides for a second. All right, so back on the slides. So again, I want you to keep in mind that we're moving beyond thinking of Redis as a cache, and we want to think about Redis as a multimodal database. Why multimodal? Because you can have an application that has part of the domain, it's a normal set of hashes or tables. Part of the domain could be JSON documents. Part of the domain could be a graph, and they can all work together under the same database. Specifically, when we have our search module that interacts with a lot of those modules to basically provide a more seamless integration too. So I mentioned the basic data types that Redis has. Now let's talk about Redis modules, which is things that are extra added to Redis as add-ons, basically. So there are 7 modules that I want to talk about. There's a lot of open source modules. These are source available modules that Redis Labs maintains. So that list starts with Redis JSON, which basically, again, gives you a JSON data structure for your Redis. Then you have Redis Search, which basically gives you the ability to do things like you can do with Elasticsearch, just a little faster, over Redis hashes and JSON documents. Then we have a time series module that basically allows you to have time series data as a native data structure. Then we have Redis AI, which allows you to run AI models on Redis. So Redis becomes a AI model server. Then you have Redis Gears, which is kind of like Lambda or AWS cloud functions, basically. So you can have either JSON or JavaScript soon functions that basically, or Java functions that run in Redis, just like a stored procedure or a stored function would be in a relational database. And then you have Redis Bloom, which basically gives you this probabilistic data structures that allow you to count things efficiently. And I think Simon Prickett might have covered that in his presentation. But the star of the day, it's Redis Graph. And Redis Graph basically provides a full-blown graph database for Redis. And if you want to learn more about the available modules, there is a Redis Modules hub where you basically have the list of all available modules. The modules provided by Redis Labs, are supported by Redis Labs and maintained by Redis Labs, are under the redislabs.com modules get started. All right, so let's talk about Redis Graph. In Redis Graph, it's a low latency graph database. What does that mean? It is a fast graph database. It is probably the fastest graph database, but keep in mind, it's still a fairly new database, so there's some features that are still not there yet because it's a very new product. But like most things out of Redis and Redis Labs, it came out the door with a high performance footprint. And it's based on something called the property graph model, which is basically it's graphs with nodes and relationships, but with extra metadata that you can have on the nodes and the relationships. And it is built as a Redis module, so you can install it on your normal open source Redis installation, or like I did for this demo, you can basically use a Docker image Redis mod that has all the modules that Redis Labs supports. So Redis Graph, again, has nodes and relationships. The relationships connect the nodes. The nodes and the relationships can have properties, and the nodes and the relationships can have labels. So the extra things that that property graph model gives you is that you have properties on the nodes and the relationships, and then you also have labels. And you can think of labels as the class. So for example, you can have a node called Brian, which is a class user, just the same way that you can have a row in a database table user for Brian. So Redis Graph uses something called the Cypher query language. In the Cypher query language, it's kind of like SQL for graph databases. And it started with Neo4j, and now it has become the standard for most graph databases. Either they support Cypher directly, or their own in-house built query language pretty much looks like Cypher. So Redis Graph implements a pretty large subset of Cypher, not the whole spec yet, but again, it's a fairly new product, but implements, I would say, I don't know, maybe 80–90% of the spec. So using Redis Graph boils down to using Redis commands. Some of those commands might be wrapped in some construct from your programming language, and using Cypher queries. So just the same way that for example, in Java, to use a relational database, you would have a Java JDBC driver that has some commands, or something like Hibernate that has some commands to deal with the data, and then you have a SQL or something like HQL or JPA queries. So let's talk a little bit about the Cypher query language before we start building stuff, so you understand kind of how things are put together with Redis Graph. So the Cypher query language, it is inspired by SQL. So when you look at a lot of the clauses and constructs in Cypher, it's going to remind you of SQL. But where I think it goes beyond SQL, it's in the pattern matching capabilities of the language. And you will see the pattern matching, it's almost graphical because it uses ASCII art to visualize the relationships between different nodes in nodes, relationships, nodes. So in that little box in the middle, there's just two empty parentheses. That is the simplest of nodes in the Cypher query language. So two parentheses with nothing in the middle means any node. And this one doesn't have a label, doesn't have an alias or a variable. And as a pattern matching entity, it will match any node in the database. So when you say select that from the database, it will basically give you every node that you have in the database. So it's almost like selecting star from every table in your database in a SQL database. So then here's a little more information about a node that we're looking for. This one, notice that there's a column and then the word actor. So this is a node that is of type actor. And we call actor, in this case, the label. So this node, it's labeled for a specific type. It's a specific type of node. So when I do a select using that, it's going to return every node of type actor. Then you can also add an alias to the pattern matching. So in this case, I want to find all the actor nodes, but when I get them back, I want to put them under the variable A, so then I can do things with that variable further down the query. So here's an example. Let's say that I want to create an actor. So I create an actor node, or I'm looking for an actor node. So one of the things that I want to point out is that this same construct that you see on the screen could be used to create the node, or it can be used to find the node. So if I pass this to a create statement, it's going to create a new node of type actor with the variable, with the alias A, and it's going to set the property name to be Catherine Han. And if you can see, the properties kind of looks like a JSON document. You can think of it as a flat JSON document. And you can have as many properties as you want to. So you could have, for example, a Java object or a Python object that can be mapped to a node in a graph database very simply. So here is now two nodes connected with a relationship. And as you can see, on the left side, we have an actor node with the name Catherine Han, and we have then a dash in square brackets with a word in the middle, ax. Ax, that's a relationship. So the relationships also have a label. So in this case, my relationship has the label ax, and it doesn't have an alias, but you can also have an alias for a relationship. And it's saying that the actor Catherine Han acts in the show WandaVision. So this is how you build the basic unit of association in Cypher. You have a node with a parenthesis, dashes, an arrow basically with a bracket in the middle with the type of relationship, and another node on the other side. And notice that it has a direction. So the direction could be on one way or the other way or bi-directional too. So Cypher has a lot of power in basically how you connect things in your graph. So now let's play a little bit with Redis Graph on the CLI so you can see, understand a little bit of how Redis Graph behaves. And then we're going to do something a little more graphical after that. And a little further down the line, then we'll turn all that into code. So let me switch now back to my CLI, to my terminal. And let me make sure that... Yeah,
hey, Brian.
Yes, go ahead.
I think you are answering this question. Are we going to present a demo for this concept?
Yes. Yeah, we're going to have... So I'm going to do the demo on the command line first, and then we're going to build code. So we're going to do two parts.
Okay. And Clayton Passos is asking too, where I find these slides? Could you share?
I will share them to you after the presentation is over. These are new slides that I put together, so I haven't really published them anywhere yet. But yeah, I will send them to you.
Okay. Thank you so much. You
no
can
problem.
go on.
All right. So I'm going to, let me just clear this screen right here. And we're going to mimic some of the things that you saw on the screen. So the first thing I'm going to do is I'm going to, one of the things I can do is I can see if there's any graphs in my database. So I'm doing a graph list, and notice that I get an empty array, so there's no graphs in our database. So then I'm going to create a node. And to do that, I'm going to use the query command. So basically, you do graph.query, and then you pass the key, which would be the ID of your graph. So I'm going to call this one IMDb GRF. So for like the movie database. So now I have the command, which is graph.query, the key for my graph, which is IMDb-GRF, and now I'm going to pass the Cypher query that's going to create a node. So I'm going to use the create clause, and then I'm going to say that I want to create a node of type actor, just like we have in the slide, and I'm going to say that the name, just like we did on the slide, is going to be the super talented Catherine Han. She spells her name pretty weird. Han. There we go. So there is the creation of one node. And actually, I'm going to add more data. I'm going to add a nickname to her, just so I can maybe do searches or some associations quicker. So I'm going to, it's just going to be the two letters of her name. So K and A. And then I have to close that curly bracket. Then I have to close the parenthesis. So notice that that whole thing in parentheses, it's a node with properties and a label. And I'm going to now close the quote for the create statement, the Cypher statement. And when I hit enter, now notice that the response that I get back is that I created one label. That also created one node. I have two properties on my node. And obviously it's super fast because it's local, but even over the wire, it's super fast. And if you look at the Redis monitor, you can see that it registered my command in here. So notice that we didn't have to create a graph explicitly. If I do a graph list now, you see that now we have a brand new graph in our database called IMDb graph. All right, so let's do a couple more things. I'm going to copy and paste this one so you don't have to see me type slowly. But now I'm going to create a standalone node for a TV show. So I'm creating the show labeled node for the show WandaVision, and also has a nickname, which is WandaVision, WV. So I'm going to click enter there, and I get my node created for that. So now let's join them with a relationship like we had on the screen. So I'm going to, again, do another query. And this time, so we'll start the query here. And this time what I'm going to do is I'm going to do a match. So the match, notice that the first two statements were creates. If I use the same node definition, but with a match, now it means find a node that matches that criteria. So I'm going to say, find the actor, and notice, rather than having to type Catherine Han, I just say KA, because I'm going to do a search by the nickname. So it's like SQL, but notice that I don't have to say match where actor.nick equals KA. You can do that, but you can also do this pattern matching with the node definition, which I find much easier to read. So I'm going to find the actor Catherine Han, and I'm going to put that in the variable A, okay? And then I'm going to also find the show WandaVision. I'm going to find it by the nickname too, by the WV, and I'm going to put that in the variable S. So notice that I have now A and S in my result set. And notice that now I can close that node definition. And after I find those two values, I'm going to create something new. So I'm going to create now a relationship between A, and it's going to be a relationship of type X, just like we did on the slides. And that relationship is directed from the actor to the show. So notice that I do this ASCII art A, the square brackets for the relationship with the label, and S for the show. And if I close that, that seems okay. And so now notice that I created one relationship between those two nodes. So now I started connecting things in my graph. All right, so that is how you create a relationship. Now let's do some querying so we can understand what's going on in here. So one of the things that I like to do, which is kind of like the select all the classes that you have in the system, it's to do, let me clear this so you guys can see better at the top. So I'm going to, again, run another query. And this time I'm going to say match. And I'm going to say match any node. And I'm going to put that result into a variable called n. So notice that I don't have to say match a node just by the label. I can say just match any node, put it into the variable n, and I want to return the distinct. So this should remind you of a SQL. So the distinct labels. So labels is a function that you have available in Cypher. And in Redis Graph implementation of Cypher. So I'm going to say, give me the labels of that those match nodes. And if I run that, I think that looks right. Notice that there's two types of labels. I have actor and show. So we kind of basically did a select of metadata of our graph. All right, so now I'm going to switch now to a graphical viewer. It's called Redis Insight, and I'm pretty sure that Guy, Royce, and Simon Prickett probably showed you this before. So I'm going to now switch to that and do the rest of the demo in there, so you can see things in a graphical way. So let me now switch to Chrome, to my browser. Let me switch the scene to the browser. Okay, so I'm here in Chrome. I want to see that. Let's go to Redis Insight. So what you're seeing on screen right now, it's the IDE called Redis Insight. In Redis Insight, it's a web-based graphical environment for Redis. And notice that I can connect to my local database. Let me go ahead and clear this here. Let me just clear some of this stuff. We don't need any of this. And notice that when I go to the there's several places in here. You can basically browse your entire database. You can look at stream data. In the one that we care about today, it's Redis Graph. So notice if you have more than one graph, it will show up in here. And the stuff that we did on the CLI, you can do here, except you don't have to put the command. The command, it's assumed to be the graph.query command. So you only have to put what we put in the string for the match. All right, so the first thing I'm going to do now is create a bunch of data so we can do some interesting things. So I'm going to copy and paste a bunch of nodes that I created here. Some of these are more actors. So I'm going to paste, let's see, one of the things that I don't like about this is that, yeah, I'm going to do a shift enter. Okay. So I have there one actor, and I'm going to add a few more. So let me add, I believe I can add multiple lines. Okay. Maybe something has changed. All right, so I'm going to just run this query here and create one actor, extra actor in here. Let me go ahead and do a few more. So I have created now 3 actors, and let me grab a few more in here. And I believe if I, I see what my problem is. I'm actually posting the whole command, and I only need the creates. So let me grab some of these. So I have another create. And one of the things that I can do as I'm doing that is I can say something like this. For example, I can say match all actor nodes. So I can basically do a select star from actor and return the actor. And if I do that, I get this graphical representation of the actors that I created so far. So notice I have Catherine Han, Paul Rudd, Paul Bettany. And in this viewer, you can also see things as a table. So sometimes it makes more sense to see it as a table. Another thing that I wanted to show you is, so I could do something like this, for example. We have a name, and we also have a nickname. So rather than seeing the object all in a single column value, I could do something like this, and now we get a nice table of values. So a lot of the things that you instinctively would do with SQL, they're likely to work with Cypher. All right, so let me create a few more of these. Let me see. So let me see how many shows I have created. And all of your queries basically are kind of memorized in here, so you can always go back to another one. And I'm going to see if I have created any shows. So we're going to have some actors and some shows. And let's just switch this to S just because it makes more sense. So let me execute that. And we have created 2 shows, the Shrink Next Door and WandaVision. Okay, so let me see. I'm going to now add a few more shows and movies in here. Let's do this. And you could also create a CSV file and import the data in bulk. And we're going to do that for the larger demo. I just want to play a little bit with the database and the graphs and the command line, because typically this is how you would learn about a system like this. You would basically play with it on the Redis CLI or on Redis Insight. So I'm going to create a few more movies. And now let me create some relationships between those actors and some of those shows and movies that I created. So let me add a couple more in here. And once I do this, we'll be able to do some fun things with the graph. So let me grab a little more in here. Because we want to play with somewhat simple queries before we get into the complex queries that basically do pattern matching for recommendations. Okay, two more. And one more. Okay, so now let me do a query, for example, to, again, let's do one to find all the relationships that we have created, all the type of relationships that we have created. So similar to the one we did for nodes, but this one, notice that I pass a template that basically has empty nodes in a relationship that only has an alias. So basically, I want to put the value of the relationships found between any nodes into the variable E, and then I'm going to filter that E by saying, give me only distinct types for E. So when I run that, I will basically get that I only have one relationship right now called acts, which is the one that we use to create the actor acts in show or movie. And now let's do another one a little more complex. Let's count the labels in the graph. So I'm going to now do a match for any node, and I'm going to return the labels and the count of nodes. So notice you have all the similar constructs that you have in SQL in Cypher. So notice that we have 3 actors, 3 movies, and 2 shows. I thought I had more actors than that. Let me double check that, unless I made a typo somewhere. Let's find our actors. Query. Somewhere in here. So the one for shows, let's just run that one first, just verify that, we only have 2. Why? I must have done something wrong on my copy and pasting. Let me see. Let's see how many nodes we have. So let's see how many actors we have. Oh yeah, somehow I did not create all the actors that I want to. Oh no, yeah, yes. Sorry. It's all good, it's all good. I forgot that I have shows and movies. So if we do, if I run another query here, if I say match, so you guys should have reminded me that I also have movies. So if I do M movie, and then I return just a movie, if I run that, notice that we have 3 movies. So we have Captain America Civil War, Our Idiot Brother, and Iron Man. And for shows, So yeah, it looks like we have all of our data. So we have 3 different types of nodes. So in here we have our shows. Okay, perfect. Now let's see. We counted the labels in the graph. Now let's find the name of all the actors that acted on the Shrink Next Door TV show. So I'm going to create a new query here. And notice that I'm going to do a match for any actor that acts on the show with the name, the Shrink Next Door. And I'm just going to return the name of the actor rather than the whole object. So that basically tells me that Catherine Han and Paul Rudd were in that show. Now, let's do a more interesting query. So I'm going to now do a query that basically finds actors that acted together in any movie. So I'm going to start with a match for actor 1 that act in a movie M. And now I can come from the other side. So notice here, this arrow coming from the other side. I want to find actor 2 that also acted in that movie. And then one of the things, I'm going to have to add a where. Actually, I'll add the where later. Let me show you what's going to happen in here, so you can understand pattern matching in graph databases. So I'm going to now return the name of the movie. So the movie, remember, it's M. And I'm going to return the name of the actor 1 and actor 2. So when I run that, notice that I get some duplication here. And hold on, give me 1 second here. I'm going to. All right, I apologize for that. My dog needed to get out. All right, so I have now notice that the movie Our Idiot Brother was repeated twice for each one of the actor combinations with the actor itself. So notice I have Catherine Han. She obviously acted with herself in that movie. Catherine Han and Paul Rudd. Paul Rudd and Catherine Han and Paul Rudd and Paul Rudd. So to fix that, this is called the permutation problem. And this happens in rule engines and also in graph databases, because you have to now add a clause to differentiate between those. So I have my match and I have my return. And in the middle, I'm going to add a where clause. In my where clause, it's going to say that I want A1 to not be the same person as A2. And the ID of A1, I want it to be greater than the ID of A2. Why? So the first one deals with the case where we have Catherine Han and Paul Rudd being matched. The second one is an ordering clause. So we only do Catherine Han and Paul Rudd and not Catherine Han, Paul Rudd, and Catherine Han. So if I run this again now, we have cleared our confusion now, and we have basically just the one match between the actor in the 2 actors that acted together in a movie, which before we had, notice that we have repetitions also for Iron Man, but it was just Paul Bettany and Paul Bettany, so that one went away. Captain America Civil War, Paul Rudd and Paul Rudd, that one went away. And then we cooked down the other list to the actual matches that we want to get, which is Our Idiot Brother, Paul Rudd, Catherine Han. All right, so that last query kind of gives us a glimpse of the power of the Cypher query language. In that relationship pattern matching with the 2 arrows, you can make that as deep as you want. You can actually have indicators that said navigate, 10 relationships deep, and then start looking from there. So you can do a lot of very powerful things with Cypher. All right, so now let's actually build an application. All right, so I'm going to now switch to the slides for a second. So let me switch back to Keynote. All right, so we did Redis in the CLI, we did Redis Graph and Redis Insight, and now let's build something. And we're going to build a Spring application. So we're going to build a set of recommendations in a Spring application. And the first thing that we're going to do is, So the first thing we're going to do is create a blank Spring Boot application. We're going to add the Java client for Redis Graph, which is called JRedisGraph, and it's based on the Redis driver for Redis. So the Java basic driver for Redis is called Redis with J, and JRedisGraph uses Redis to implement the commands to talk to Redis Graph. Okay, we're going to create a graph from a pre-made CQL file. So basically, a file that had a bunch of commands like we did on the CLI and on Redis Insight, but they're all in a single file, and we can just slurp them all in. We can just suck them all into the database in one shot. So no more copying and pasting. And then we're going to implement a Spring service and a controller to basically do some queries against those graphs to provide recommendations in our system. All right. So before we get to that, let me explain what our domain is going to look like. So we have something called, I created a little application. So this is just a portion of a full-blown application that we have on our GitHub repository. And this one, I just basically took everything else out and just left the graph part. But I will also give you the link for this one, which basically has everything. So, and it's called Ready to Read, and it's an e-commerce, it's a simple e-commerce application built in Spring Boot that basically uses Redis for everything. And it does uses Redis JSON, Redis Search, all the Redis modules basically. And the graph part creates a graph where you have authors. So I have the label on the left, the author authored a book. We have books in categories, so the relationships are in red. We have a rating, so a user rated a book, and I believe I did a 5-star rating from 1 to 5. And also, we don't have a cart in here because I didn't want to put too many entities in there, but there's a direct relationship between a user having purchased a book. So those are the 4 nodes that we have. So we have author, book, category, and user. And then we have 4 types of relationships: authored, in, rated, and purchased. Okay, so before we do that, sorry, let me switch to the browser again, and we're going to create our Spring Boot application. So let me switch to the browser in Chrome, and I think I already have a tab open. Yeah, so I have the Spring Initializer here. And again, if you're not a Java developer, this might look weird, but I'm creating a basic Spring application using something called the Spring Initializer, which is basically a website provided by Spring that allows you to get a zip file with either a Maven or Gradle project, and it could be a Java, a Kotlin, or Groovy implementation. And it's really nice. It basically gives you the ability to pick your version of Spring, the type of builder that you want to use, the build system, either Maven or Gradle, the language. And in here, we're just going to let me remind myself of what we're going to put in here. Okay, yeah. So first, let me pick some dependencies. So we're going to use the basic web dependency, Spring Web. That gives us the ability to do the RESTful web services. We are going to, I always add Lombok. I don't think I'm going to use it for this one, but just in case, let's do that. And so I don't have to restart the server every time I change the code. I'm going to add the Spring Boot developer tools. And I think from Spring, that's really all that we want. And normally, I will change the package. I'll change this to Redis Labs. And I think I'm going to call this just recommendations. So our artifact, our application, basically, it's called recommendations. And that looks good. We're going to do a jar file. That's the easiest thing to do. We're going to do Java 11 is good. Don't do Java 8. That's already too old. So we'll stick with 11. And now I'm going to click on generate, and that's going to create a zip file that is going to be downloaded to my downloads directory. So I'm going to now switch to the command line again, and we're going to unzip that file and start our application. So let me switch to the command line again. I'm going to go back to the terminal. And on the terminal, I'm simply going to, so in here, notice I have my ready-to-read grf CQL. That is the file that contains all the commands to create the graph that we're going to use in the demo. But before I use that graph, I'm going to unzip the file that should have been downloaded to my downloads directory. So it should be that one. So recommendations.zip, that's what the Spring Initializer created. I'm going to, now I should have a recommendations folder in there. And let's switch to that recommendations folder. All right. And in there, we should have a basic Spring Boot project. Let's actually open it in Visual Studio Code. So let me switch to Visual Studio Code so you can see what we have. Let me make sure that you guys are seeing what I'm seeing. Yes, it should be there. Okay. So notice I have that CQL file. Let me show you that quickly. Notice that it has just a bunch of graph.query create statements and match statements to basically create our whole graph. And it's a significantly big graph. I believe I took data from the Google Books database, and then I also created random users, and I wrote some code to categorize those books and then create categories and all that stuff. So in here we have a more complex graph. And I did this CQL file just with basically raw Redis Graph commands to create this ready-to-read grf graph. But you can also create a graph from a CSV file, and it will be faster. This is actually just, it was easier for me to generate it with code this way. But you can also do a bulk import with CSV, and also you can do imports from a database. All right, so let's look at the recommendations application. So on the recommendations, I have a traditional Spring Boot project. And if you look at the POM, the build file, notice that we have the dependencies that we added. So Spring Boot Starter Web and Spring Boot Dev Tools. That's really basically all that we were able to specify in there. And now I'm going to add another dependency. Let's add a dependency. I'll add it right here before the test stuff. So I'm going to add another dependency. In this one, it's going to be for the Redis Graph library. So I'm going to, I already have it here in a text file, so I don't have to type all that XML. So I'm adding the dependency from Redis Labs called Redis Graph, version 2.3.0. And that's all we need, really. And I can actually now switch back to the CLI, and let's make sure that we can compile and launch the application. It's not going to do anything right now, but we should be able to do so, to basically build it and run it. Well, so I'm just going to do an nvn install first, just to actually, and we can do mbnw install. And that's just to make sure that we can get all the dependencies and build the application. And it's obviously it has one fake test which comes with the generation of the project. So we have a success. Okay, good. So we have a application that it's basically working. Now let's go back to the Redis CLI and let's do show our list of graphs. So we only have one graph, the one that we created manually. So now let me run a command to basically load the data into the new graph. So one directory above from these recommendations, is where we have the ready to read, the graph CQL file that I showed you before. And what I'm going to do is I'm simply going to do a cat command on that file, and I'm going to pipe it. Into the Redis CLI. And to make it faster, I'm going to use the pipe flag. So this is a way to basically, I'm saying, if you're not a Unix user, cat basically it's outputs the contents of that file, and then I'm taking the content of that file and I'm passing it to the Redis CLI command with the pipe flag. So once I do that, notice that immediately I get all the data that's transferred, waiting for the last reply, so doing everything in bulk, and I should get a reply from the database any second now. Notice that it's basically now creating, running all those statements. And once it gets to the end of it, we should basically have our graph was created. So now we have all data was transferred, and we're waiting for the last reply. We got the last reply, no errors, so we're good. If we go back to the Redis CLI and we do the graph list, notice that now we have two graphs. We have the one that we created before, and we have our ready to read graph. If we do, for example, let's see, one of the commands that we used before to list the types of nodes. Let's see if I have it somewhere in here. Oh no, we did that. Yeah, let me go ahead and steal that one again so we can see what type of nodes we actually have. Yes, here, this one will do. Okay, so I'm going to do another graph.query, and then our new query is our new graph is called ready to read that graph, and I'm going to pass that query that counts, that gives me the distinct labels and counts them. So notice that we have 647 authors, we have 437 books, we have 16 categories, and we have 1,001 users. I think I meant to do 1,000 users, and this is a +1 error that us developers do all the time. Okay, so now we know that we have our graph in there. For completeness sake, we can let's just see what type of relationships we have. So I'm going to just copy and paste the query that we used before for the other graph to see the number of relationships. So again, I'm matching this empty template of our relationship and grabbing the types, and notice that we have those in, authored, rated, and purchased relationships. We can also do what we did before and just count them, see how many of those connections we have in the system. So I can count those, and notice that we have 729 authored relationships, 435 in relationships. So those are for the categories. So it should match. Oh, so we have 2 books that were not put in a category, and we have 3,794 purchases and 5,000 ratings for our books. All right, good. So now that we have the driver, we have the database loaded, now let's actually go and implement something. So first I'm going to show you what the query looks like in the slide, so we can talk about it a little bit, and then we'll implement it in the code. All right, so I can go ahead and close that POM. Let me switch back to the slides for a New York minute. Okay, so we're back in here, and now I want to show you the first recommendation graph query we're going to use. In this one, it's, sorry, you guys seeing the right one? Yes, so we're going to talk about getting book recommendations from common purchases. And if you see on the screen, we have a pretty long query. It has 2 match statements. It has a where clause with a not to negate something. And then we have a return clause and an order by. So let's talk about each one of those items one by one. So at the top, we have, notice that we have a number, an ID in there. And that ID is just an example. What we really want to do is take the ID of the user that we want to provide recommendations for and put it in that placeholder. So that would be the ID of the user that we want to provide recommendations for. So the first match, it's going to anchor the whole query for that one user. Then we're going to find any book that that user purchased. So we're going to do where you see the OB column book. We're basically collecting all the books that the target user purchased. Then we're going to find other users, any user that also purchased that book. So the second match is looking for users that also purchased that book. And then we're going to collect, notice from the user node in the second match to the right, we're now also finding all the other books that that user that bought the same book as our target user purchased. So notice that we have OB for the books of the target user and B for the books of the users that also bought books that our target user bought. That sounds complex, but it's not. In the where clause, we're trying to eliminate the books that we already have. So if the target user already purchased any of the books from the association that we are following, then we can eliminate those books. So the where clause is saying, don't show me any books that I already own. Then we're going to do a return statement, which is going to be return the unique list of books from the user that purchased books that I purchased too. And I want to count those books, and the count is going to be the frequency. So basically how many of those books the collective set of users bought. And then we're going to rank them by that frequency. So by the count of how many were purchased. And then we're going to order that list by that frequency so we get the most popular books at the top. So before we jump on the code, let's actually try this on the CLI. On Redis Insight. And what I want to do is first find a random user, and we'll use that as our testing. So let me see. I have a 1 second. Okay. So I have a query to find a random user, and I'll show you that in a second. Let me switch to Redis Insight. So go back to the browser, Chrome, yes. So in Chrome, I'm going to switch again to our Redis Insight tab. And notice that now we only have one graph in here. We need to refresh this page to get, now we have multiple graphs in our dropdown. So let me go ahead and delete some of this garbage that I have in here. Obviously, I was testing and playing with this before. So I'm going to do, our first query is going to be match any user, put it in the variable u, return the user, but order it randomly and limit the result to 1. So that way we can get one random user. So I'm going to do that, and notice that I get Jeremiah Bates. And really all I want is the ID for Jeremiah Bates. So before I put that ID, let me grab the query for our recommendations and see if this user has any purchases that other users have also purchased, then we should be able to get some result. So let me find, yeah, I have my query right here, and I'm going to paste the query. And I'm going to grab the ID of the random user that we collected. And let's see, that looks correct. So I want to execute that. And notice that I got a little collection of books. So I can go ahead and, for example, zoom into this and look at what the books are. So I have 7 databases. And well, by the way, these are all computer books. JavaScript and Open Data. So these are all the books that are being recommended, but they're not in order. To see the order, we can look at the table and notice that now we have, well, for this user, basically all these books were just a single purchase. So all of them are equally valid in here. Let's find a different user, see if we get a more interesting. So we got Chloe Stone. Let's grab the ID for Chloe Stone. And we'll put it back into our recommendations query. And let's see if we get a more interesting list. So we have 257 books. I am going to guess that there's got to be some ones with different frequency. Or did I? Let's see, maybe I put the frequency backwards. Oops. Obviously, this is not real data. I generated the purchases randomly. So it's a matter of finding the right user to get basically a nicely ranked list, because otherwise these are all single purchases. Let me try it one more time. I'll try one more user. See if the demo gods find us a user that has a better collection of books. So we got Violet Douglas this time. Let's select that user, grab the ID. Did I copy the whole thing? Oh, no, I missed it. Good thing I caught that. Okay, so I'm gonna grab the ID of another random user, and let's try one more time to see if we actually get a better result. Obviously, with randomly generated data, you get what you get. Okay, so 235. Let me change the, let me take the sending, see if actually that gives me a better, maybe I had it backwards, no? Interesting. Yeah. I must be hitting just single purchase users, I guess. All right, okay, but the query works. Right now, we just have some purchases that were very sporadic, single purchases to those users. So we're not getting a bulk of values out of our system. But now let's go back to the Java code and let's implement this. So I'm going to once again switch to VS Code. And all right, so in VS Code, I'm going to, normally I would create multiple classes for the service, for the controller, but to make it simple, I'm gonna put it all in the single recommendations application class. So we're gonna put some classes in there that otherwise I would put somewhere else. All right, so we're gonna start first by creating a service. So I'm gonna create a very simple service. One of the things that I wanna do, that I normally do, it's pass the name of the graph as an applications property, so I can read it into the graph, and then I can switch the code between different versions of the graph with different data. So I'm going to put a application property called app.graphID with the name of our graph. And now back in the code, I'm going to create first a service. And I'm going to do a little bit of copying and pasting to move things along. So right below my main class, I'm going to do a package level class annotated with service called recommendation service. And notice in here, I'm bringing the name of the graph that we put in that properties file, app.graphID using the @value annotation. And I'm putting that into the graph ID string variable. And I'm also instantiating an instance of the Redis Graph client. And I just called it graph. So Redis Graph, it's a new Redis Graph. I'm not worrying about resource management in here. This is not how we do this in production. I just want to basically get something going so you can see the queries working. So we need some imports to basically deal with this. So the imports that I want to bring in, basically everything from the Redis Graph library. So we have a record and a result set. So a result set has records, and then I'm bringing in the node entity, and I'm also bringing in the actual Redis Graph driver, which is what you see here. Okay. And let's see, what else do we need? We have the Spring Boot application. We're going to do a controller too, and we need the service annotation that we use in there, and the value annotation that we use to bring the name of the graph. So I'm going to copy and paste those imports from the Spring framework. So in other words, we have the value annotation that we use below, the service annotation. We're going to be using the AutoWire annotation in a second. And then I also need all the RESTful service related annotations and methods. So I have the get mapping, path variable, request mapping, and REST controller. So in our service class, which is empty right now, the first thing we're going to do is create a method for the top and most purchase books, which is going to reflect that query that we just seen on the Redis CLI, on the Redis Insight. So our signature of our method is going to return a map of strings and longs. So just like the table that we saw in the Redis CLI, we're going to return the ISBN or the ID of the book, and then how many units were purchased for that book. And we're going to pass an integer that's going to say we want the top 10 or the top 20 or the top 50. So we are going to collect those into a same type of structure. So we're going to collect those values into a map of strings and long. I'm going to call it books with purchases. And at the end of the method, we also want to return that. So at the end of the method, we're going to return the books with purchases. Now, to run our query, we need to stringify our query into a Java string. So I'm going to do that by just using string concatenation. So very simple. But notice that the one thing that I'm passing, I'm going to use a string format method, because that n value is going to go into this %d. So for that, we will use the string format method to pass the query correctly. So to run the query, it's actually pretty simple. And I'm going to do this by hand so you can kind of get an idea of how this is done. So I'm going to create a result set. So my result set is going to hold the results of the query, just like a JDBC result set. And let's just call it result set. And then I'm going to use the graph client, and I'm going to invoke the query method. So basically, this mirrors the query command in Redis Graph. So basically, it calls that command under the covers. And then we pass the ID of our graph, or the key for our graph, which is graph ID. And now we're going to use a string format method to basically turn our query and do that replacement of that integer value. So I'm going to take the query and pass as a single parameter that integer n, and I'm going to close that. And then, like any result set in a normal database, in a relational database, you can iterate over the result set. So I'm just going to do a while loop. So let's keep it simple. You could use Java Stream API and make it nicer and cleaner, but this is going to be easier to understand. So I'm going to loop over the result set. So while there are any elements left in the result set, I'm going to then grab each row. It's a record. So I'm going to grab the next. The iterator basically returns a record. So that's hoping that it's not a SQL. Sometimes it tries to get smart and guess that you're using SQL, and it's not. Make sure that I didn't put an import for that. We have result set. Yes, good. Okay, so we're going to grab the next value on that result set, which is a record. And then just like a SQL result set, you have columns. So I'm going to grab values out of the column. So I'm going to grab a node. And the node that I'm going to grab comes out of the record by the name that we use for the variable or the alias in the query. So in this case, it's B. So now, if you look at the query above, notice that we have this B right here. So B, it's what we pass in here to get that column of the result set. So fine, we got a node. And the other value was the count of the purchases. So for that one, let's actually grab, that's going to be a long, I believe. Yes, it's a long, and let's just call it purchases. And that also will come out of the record and would be a value under the name, I call it purchases too. Okay. So notice the driver is smart enough to know that this get value, it will be typed to basically what you're asking it to return. So now we have the two values out of our result set, or out of a row of the result set. And now let's just add them to our books with purchases. So this is a little not performant because I'm looping, taking things out, putting them now into a hash to return it. So there's quicker ways to actually do this, but I wanted to make sure that you see how to interact with the driver in the result set. So I'm going to now, from the book node, I'm going to get, wait, this is trying to do a lot of guessing for me. I think I installed a system that kind of tries to guess on your IDE what you want, and it's guessing all the wrong things today. So in my books with purchases hash, I'm going to first put the property ID of the book. So that should be the ISBN. And that property, we need to get the value out of it. So I'm gonna get its value out. And I also need to turn that into a string. So I'm gonna turn that into a string. And then the second value, so the key would be the ISBN of the book, the ID of the book. And then the second value is just gonna be that count of purchases, that long that we created above. So that we got in place, that's all we need for our service. So our service should be complete. We have the Redis Graph driver, we have a method that takes an integer n, then we create our query, pass it to the driver with the query command. We are replacing that, that limit value with the passed integer, and then we loop over the result set and grab things out of it, just like we would do it in any normal database. So let's actually write a quick controller to pull some of that data out. So the first thing I'm going to do is I'm going to create a very simple controller, and I'm just going to copy and paste this so it's a little faster, because we are getting close to the time. So I'm going to create another class in the same main file. And in this one, I'm creating a REST controller, and it's going to map to the API recommendations. And I'm calling it recommendation controller. I'm using the auto-wired annotation to inject that recommendation service into our controller. And then we have a /ISBN top sellers passing the end value. We grab that from the path and we pass it to our recommendation service method, and that should return what we need. So let's switch to the command line, see if all this compiles, see if we didn't forget any specific imports. So let's switch to the recommendations folder. And in the recommendations folder, let's just try to run it outright. So let's do an MV and W. So let's clean and Spring Boot run. It's the command to basically run a Spring Boot application that's been packaged as a single jar. So let's see if we don't have any errors. Oh, yeah, we have an error. Let's see. We're missing probably, map. We're missing some of the Java main base util classes. So let me go ahead and copy and paste those because I think I know. I'm just going to do import Java util star, and that should do it. So let me switch back to the IDE so you can see how the sausage is being made. So VS Code, and right in there, I'm going to just add an import start for Java util, and I'm going to switch back to the iTurn now, and let's try this again. Let's see if we don't have any other errors. That is looking better. Yep, it looks like we're starting. All right. Okay, so now let me switch to, let's do it on the browser first. Let's do it on the browser. We can use curl, but let's just do it on the browser and save ourselves some time. Let's look at what is the root of our request. If I look back at the controller, we called it /API recommendations. Let me start building this request here. So I'm going to do an HTTP column, localhost, but it's 8080. And delete the beginning of our API. It's API recommendations. That's what we use in the controller root. And our method, it's under ISBN top sellers, and then you pass it how many top sellers. Okay. Nobody called me on this. I implemented a different method, but hey, let's see it working because it's the same principle. So for this one, and I'll go back and I'll talk about the query in a second, but for this query, it's looking for the top sellers based on a book, on just a general list of books. So let's just do 10 here. If I do 10, notice that I get back an array, a hash or a JSON object that has the combination of ISBN. So if you look at, let me make it a little bigger. So I have ISBN and the count, 17, 20 of those, 21 of these, 24. So there are some recommendations based on the top sellers. All right. So now let me go back and actually implement the method that we really wanted to implement. So I'm going to switch now to VS Code one more time. And we should be able to finish all this in, I think, the amount of time that I wanted to use. Okay, so that was the very simple query for top and most purchased books. Now, let's do a similar one, which is also fairly simple. This one would be the top and highest rated books. So I'm going to add, I have the method already pre-prepared. I'm going to add that to the service class. And notice that this one is top and highest rated. It's exactly the same structure as the prior one. But the only difference is that I'm collecting the average. So notice before I did just a count. I did a count of purchases. In this one, I'm using the average function. And I'm saying average the ratings for a given book, and then order everything by that average rating. So, and the rest of it looks exactly the same. We're extracting the B book variable. And the value of this time, it's a double, not a long. And it's called average rating, as we named it in here. Notice that you can do aliases with as, so average R rating, which is the relationship, as average rating. And then I'm grabbing that in here, and that's going to be a double. And then I'm also populating a map that has books with ratings, which is a string and a double. And obviously, we need to have a way to access that from the outside world. So we're going to use the controller to add a method to access that one. So that would be the top rated method. And again, I'm just going to copy and paste it in the sake of time. So again, very similar. We have ISBN top rated. I'm going to save that. And the application should be restarting right now. Let me switch to the browser, and this would be top rated instead of top sellers. So if I do, give me the 10 top rated ones, I can just change that part in there, and Now, notice that the values are doubles in here. So I have this one got 4.6 stars, 4.44 stars. And again, you could then come up with a UI, maybe something on React that does some kind of nice way to present those. With just the ISBN, you have to look up those books from the database and display them. And it's okay to have a graph that only has partial data from maybe a full-blown JSON document database, or a Redis hash, or even a relational database that's outside of Redis. Okay, so now we have two very simple recommendations just to get basic things from our system. Let me go back to VS Code, and let's beef up our service more. So this time, we have our two simple queries implemented. Now let's actually tackle the one that I wanted to do before, which is the book recommendations for common purchases for a given user. And this one is actually, again, a much fatter query, the one that we talked about on the slides. So I'm going to back into the service class. I'm going to now add this method. And let me explain the, I just added, yeah, I just added the body. 1 second. Okay, let me grab the whole method. Okay, so here we have, and let me make sure that you guys are looking at what I'm looking. Yes. So I'm going to add this new method called get book recommendations from common purchases. And this is the query that we had on the slide before, the one where we basically look for the books that the user has purchased, and then look for the books that other users that have purchased any of the books that I have purchased, and then I'm removing the ones that I already have and returning the frequency of those books in there. We were getting all ones in here, so it could be that I actually screwed something up in my query, but I believe this was working fine before. So I'm going to save that. So I have my book recommendations. Notice that my query, again, it's the same structure. I do the graph, the query to run the query. I'm using string format to do the user ID replacement into the ID of the node of the target user. And then again, we loop to the results and grab the values. So now let me also add the matching controller method to get that specific set of recommendations. So back in our REST controller, I'm going to now add another method here. In this one, it's called user recommendations. I guess it was very simple. And it's under user, and you pass a user ID, and it's going to give me recommendations for that user. So I'm going to go ahead and save that. And let me go back and try to grab another random ID, see if this time we have better luck. See if I can prove my theory that I did not make a mistake, but I just have data that is not as usable as I wish it was. So I'm going to switch back to Chrome for one short second here. Yeah, so I'm back in Chrome, and I think I can look for the random user. Yeah, so here's my random user. Let's grab a bunch. Let's grab 10 users in one shot, just in case. And also, let me return the ID of the user so we can just grab it directly from the table. So I'm going to run that, and I got a bunch of IDs. Let's grab one that doesn't have the negative value. See if we have better luck with that one. And now I'm going to switch to our browser again, to the other tab. And let me refresh my memory of what the URL is. So it would be /user/user ID. So very simple. Okay, so I'm here now. I can basically say API recommendations, and it should be just user. And I'll put the ID that we collected. Let's run that, and see, now we got more data than before. So that's good, but I think I'm missing outputting the actual count of those books. So let's go back to VS Code. So back in VS Code, let's see. So, oh yeah, so I was returning just a set of string. Let's see, what was I collecting? But we do have the frequency. So yeah, maybe there's some mistake in here, but let's quickly change this to what we had before. So I think this is a long, and let's call it frequency. And then I'm going to say record get value. And then it's just called frequency 2 in the query. And I'm going to, of course, I'm going to change this to a map. So this is going to be a put. And then it's going to be a, let's steal one of the ones that we have here. Yes. This one should match. So I'm going to steal that map definition, which is a string and a long. I'm going to put that in there. Let's just change. It's going to be recommendations. And recommendations, put. I need to change the return value of the method. There, and equally, since we have we're passing the same data type in our controllers, because Spring is smart enough to basically turn that into a nice JSON representation. So I'm going to go ahead and save this. Let me give it a couple of seconds for it to restart. Let's see, no mistakes. Yep, it's running. Okay, so I'm going to switch back to the browser again. And I have 7 minutes. All right, so if I execute this now, no, I am pretty sure now that I have an error in my query because I'm not counting correctly. I'm just returning 1 for each one of them. It's probably because I have a distinct clause in there. It will be more interesting actually to fix that. So let's go fix that in the 7 minutes that we have. 6 minutes that we have. I think this is causing this because by adding the distinct in there, I'm making the count 1. I think that's the problem. So I'm going to go ahead and save that. Oh yeah, you guys didn't see what I did. Sorry. Let me switch to the VS Code. Let me backtrack a second in here. So basically, we had this distinct clause in here, and I should probably make that capital. I like that better. So we have this distinct clause in here under B, and I think that basically collapsed all the instances to a single one, so the count always returned 1. So that's where my bug was. So I'm going to go ahead and kill that distinct. Let me save again. I'm going to wait for the server to restart. Let's see how fast we can do this. Switch to Chrome now. And the server has restarted. And let me refresh this. Come on. Okay. Did I not save it? All right. Well, the demo guys are not with us on this one. So, okay, now let's do the last one. The last recommendation. And this one is actually going to be also a little more involved. It's actually more involved than this one, but I am pretty damn sure that one is working. So, let's see. Are you guys looking at VS Code? No. So on VS Code, I just copy and pasted this method. And this one is called frequently but together. It takes an ISBN, so the ID of one of the books. Again, I'm just returning a set of recommendations. I'm not going to change this to return the frequencies, but the rating, sorry. And in this one, I'm basically doing the same thing that I did before, but now I'm creating, I'm basically finding all the rated relationships in here. Notice that I can put those in a variable. This is one of the nice things about Cypher. Notice I have 3 matches. I'm finding the user. I'm finding the books that have been purchased in common with me, and then I'm finding the ratings of those. and then I am basically sorting them and counting them with the by the number of purchases and frequency. And then I'm going to sort them by the average rating and the frequency, and return that to the user. So similar like we did before, let me grab a controller method that is going to expose that. And basically this is the equivalent of saying find books that typically are bought together by other users. So if user bought, let's say Java in Action in Maven for Dummies, then those two, if that pairing happens frequently, we're counting those pairs and then returning that to the user based on ratings and rankings and all the things that we had in there. So I'm going to now, once again, wait for the server to restart. And 3 minutes to go, let's switch back to the browser. So switching back to Chrome, we should be able to invoke that one, and that one was ISBN pairing. So let me grab that URL. So back in our browser, we're going to switch from user and that value to ISBN pairings. Let me grab, we have a bunch of ISBNs on screen, so let me grab one from here. I'm going to grab this 17 value right here and put it in the path where it should go. And if I run that, now I get the books that are frequently bought together in the pairings, basically, for that specific book. So for that book, these are all the list of book IDs that typically are purchased with that book, ranked by by popularity and also the frequency of that pairing. So now here you have all the IDs. And again, with graph databases, you can do very interesting things. So you can start basically following this list and see where it gets you to. So you can actually, in the query itself, you could build this way of chaining deeper into things and matching other things. And you can see Redis Graph, obviously this is running locally, it's super fast. And let me switch to the slides now to basically close the show. But that query that we just saw is this one, the books frequently bought together. And again, to break it down, it's we match the users that have bought the target book. Then the second match basically finds other books purchased by those users. The third match finds the ratings of any of those books. In the with clause, it's basically gathering all the values, counting the number of purchases for the collected books, and grabbing the metadata for the ratings. And then we are basically returning the collection of books ranked by frequency, basically. Fairly simple. So closing thoughts. I am really becoming a fanatic of graph databases. If you think about it, object-oriented languages are all about classes and objects and how those classes and objects are related to other objects. So I think a graph database might be a better pairing with an object-oriented language than a relational database. And also, the combination of Redis and Redis Graph, if you've used Redis before, you know it's fast, you know it's reliable. Now Redis lets you keep your data in whatever format you need to keep it. So graph, hashes, list, it could be JSON documents. So you can also have search capabilities over all that stuff. So it's a very powerful offering. Graph databases, they fit a number of use cases. And when you're starting with something like a recommendation engine, a graph allows you to start figuring out what the algorithms that you might want to use to either further refine those searches or those recommendations are. So I would start a recommendation engine first. If you have a relational database, just try some SQL queries. Once you get past, you hit the upper limit of that, extract some of that data into a graph. and then use the graph to basically find what those relationships between things are that you might not have seen clearly in a relational database. Then you can apply things like AI, like for example, do extraction of the content of, let's say, a book abstract, and then using things like cosine similarity and things like that to do more advanced refinement of your recommendations. But again, with Cypher, you have the ability to have this playground to really extract knowledge and understand your data in very powerful ways. So the Redis Graph website, it's on the screen. And like I said, I will make the slides available to John. And if you, I'm obviously work for Redis Labs, so we have a lot of examples of how to do things. Most of the ones there by me are Java-based using Spring. So if you're a Spring developer and you like Redis and you want to find amazing things to do with Redis, look at the Redis developer site, which is developer.redislabs.com. And I am also part of Redis University. So if you want to learn about Redis, this is completely free online classes, very well done, beautifully created, crafted classes about Redis in solving real problems with Redis. And that's at university.redislabs.com. And thank you very much. We actually finished 3 minutes late, so I got 3 minutes past the 2 hours. But I'm grateful that you stuck here for a while and watched me try to build stuff with Redis. So
don't worry about time, Brian. When you get some content as great as yours, we can talk about it all night long.
Awesome. Well, I hope everybody enjoyed this. I know it's fast-paced, but yeah, experiment with Redis Graph. I'm really excited about the things that I'm able to build that were very difficult to build with relational databases. So I'm a fan of graph databases. So another very capable one, it's Neo4j. Neo4j it's more mature, not as fast as Redis Graph, but those are the two that are my favorites. Redis Graph and Neo4j are basically the same type of animal. It's just if you already have Redis data and you want to use that data to create graphs and you want to have those queries be the fastest that they can be, then Redis Graph is the answer.
That's pretty great. Thank you so much.
Thank you, guys.
If you guys have any questions, it's time now. So you're back here in almost 3 months.
Yeah, let's plan for that, and I'll try to refine my Portuguese to see if I can actually do the presentation in Portuguese. So. Okay. I can speak Spanish like a Panamanian or a Venezuelan, so I can speak Spanish really fast. So if I practice enough in 3 months, I think I can get my Portuguese to be good enough to basically follow along a presentation.
Ok. If you didn't help, você pode simplesmente falar comigo também.
Muito obrigado.
You're very welcome. So I think we won't have any questions by now. We have some in the middle of your talk. I pass it to you. So you will give me the slides?
Yes, yeah, I will send you a PDF of the slides. I'll probably do a little bit of cleanup because I just finished the slides last night. So okay. I need to do a pass now that I've used them. I'll clean them up and I'll send them to you, and you're free to post them to the group.
Will you post in your own lecture or something?
Yeah. And there will be an article on Redis Developer following this presentation. Because normally what I do is I do a presentation, I see how things work, see if there were things that the order didn't feel right. Then I'll probably do it one more time, refine it more, turn it into a video, and then write an article with it and put that on Redis Developer. So normally I like to have the article, the GitHub repository, and the video.
Okay, that's a pretty complex process.
Yeah, we'll keep you guys in the loop. So we definitely want our Brazilian friends to use Redis And yeah, I mean, one of my favorite programming languages came out of Brazil, Elixir.
Oh yeah, it's
Yeah,
pretty good.
I love Elixir. It's amazing the stuff you can do with that. So I think it's Plataforma. I can't remember the name of the company, but yeah, it's a really some amazing things coming out of Brazil too. So
Yeah, we'll have a talk about Elixir in our channel here.
oh, great! Yeah, I have some pretty cool demos on Elixir. So maybe I'll do an Elixir presentation with Redis for you guys.
Okay, you can do it. You can schedule it at any time.
Excellent, great.
Okay. And guys, we have the social medias of Brian in the description of this video, so follow him in the LinkedIn and Twitter and everything, and follow us as well. So, have anything more to say, Brian?
No, thank you for sticking around for this. I know it's being virtual. I feel free to do longer presentations, but well, thank you very much, guys. I appreciate it.
You are very welcome. Thank you, everyone. Thank you, Brian. Thank you, Guy, to help me to set this thing up. And thank you, everyone. I think we are going now. So that's it. Bye-bye, developers.
Bye, guys.